Hey everyone. Even though I did this in class, I want to make a short little video where we solve this last Maclauren series problem. We find the Maclauren series of f of x equals x cosine of 1/2 x to the cubed, and we also find the radius of convergence. The way you do this is you first have to recall that cosine of x has Maclauren series, the sum from 0 to infinity of -1 to the n over 2n factorial x to 2n, right? And remember that equals 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus etc. Right? Just to recall. So anyway, what we're going to do is we're going to plug in cosine. We're going to plug in 1/2 x cubed to cosine and then multiply it by x, right? I'll say x times the quantity cosine of 1/2 x cubed is going to equal x times our summation from 0 to infinity of -1 to the n over 2n factorial times the quantity 1/2 x cubed to the 2n, right? Those are the substitutions we're making in green and red. And now all we're going to do is simplify stuff. And remember, what we're trying to do is get the coefficients isolated and get x to just a clean power without being in parentheses. So this just takes a little bit of algebraic manipulation, right? We're going to put x inside the summation. Going to do the exponents out. Right? We're going to get some -1 to the n, 2n factorial. You're going to get, maybe I'll put x on the outside right here. And then this is going to become 1/2 to the 2n. Times x cubed. Maybe I'll do that in red. X cubed to the 2n. Right, and just a bit of algebra right here. This is going to simplify to be -1 to the n, 2n factorial. We're still going to have an x right here. This is going to become 1/4 to the n, right? Because 1/2 to the 2n is 1/2 squared to the n. And this is going to be times x to the 6n. Okay. Now at this point, I can drop the colors, right? I can just say, well, look, we're going to have -1 to the n over, I guess this is going to be 4 to the n, right? That 1/4 to the n. Maybe I'll put that in red just to emphasize where that went. And then this is times 2n factorial. And then this is going to be multiplied by x to the 6n plus 1, right, in green, just so you see where that x came from. Right, so that's what we have. That is the Maclauren series, right? And as you can see, we have the coefficient by itself, right? That's isolated, and then of course the power of x is isolated as well, and that's exactly what we want. When I ask you find the Maclauren series of something, that's what I want if it's possible. Okay? Now we want to find r, the radius of convergence. Use the ratio test, as we usually do, as we always do, unless we're dealing with 1/1 minus x or something along those lines, right? Right, so we take the limit as n approaches infinity of the absolute value of, this is going to be 1, well, I guess I'm gonna put the x over, yeah, just over the whole thing, right? It's going to be x 6n plus 7, right? Because we're adding 1 to n. This is all going to be over 4 to the n plus 1, 2n plus 2 factorial. And remember, times the reciprocal of the nth term, right? We're dividing by the nth term. N plus first term divided by the nth term. Right, and maybe you can notice from here that this is going to be the limit as n approaches infinity of, we're going to get the absolute value of x to the 6n plus 7 over x to the 6n plus 1 times the absolute value of 4 to the n over 4 to the n plus 1 times the absolute value of 2n factorial over 2n plus 2 factorial. I won't forget those absolute value signs, okay? And how are those going to cancel, right? Well, we're going to be left with an x to the 6th there, be left with a 4 there, and then this is going to be times 2n plus 1, right? Because 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n factorial. So anyway, after all of that, we're left with the limit as n approaches infinity of absolute value of x to the 6th all over 4 times 2n plus 2 times 2n plus 1. And of course, as n increases without bound, but x does not, we get an answer of 0. Well, that means that the radius of convergence equals infinity. And of course, the interval of convergence is also negative infinity to infinity.